Hello, let's look at a competitive exam problem from the Bohr's atomic model topic. So here we have three photons which are coming from the excited atomic hydrogen sample and that are picked up, and their energies are given as follows. And we are supposed to find out that these photons are coming from how many atoms, right? So the options are given. Let us consider the last option, let us consider the C option and move on. Then eventually we will be understanding about the correct answer. So here I am drawing first orbits of three different hydrogen atoms. This is hydrogen atom A, B and C. Second orbit, third orbit. In hydrogen atom we know that electrons are always present in the first orbit, and let us move this electron from first orbit to the third orbit, right? Now this electron cannot stay in the excited state for a long time. It can stay there for maximum 10 raised to minus 8 seconds. And afterwards it is going to again fall back to the ground state. So this electron in the third excited state, this is an assumption that I am making, that suppose this electron goes from here to here. So this electron will fall back again to shell 1 by two ways. Either actually it can directly come down like this. So if it comes down, the difference in the energy would be liberated in terms of photon. And the difference in the energy of shell 3 and shell 1 is 12.1. We already know this. So this is the photon that is going to be emitted out. This electron can actually fall back in this way also. It can fall back in steps, like from 3 to 2 by emitting one photon, and the difference in the energy of third orbit and the second orbit is 1.9 eV. And when this electron again jumps back to the ground state, so again another photon of energy 10.21 eV would be liberated, because 10.21 is the difference between the orbits 1 and 2 energy gap. Now third case, these are three different atoms. So the electrons were present in shell 1 and shell 1. Then I have moved this electron to shell 3, I have moved this electron to shell 3. So there are two ways of coming down, but this electron which was in shell 1, now I am moving it to shell number 2. Now this electron, when it comes down, there is only one way, and this is going to liberate a photon of energy 10.21. So this is what we have considered, right? Okay. Now, so if there are three distinct atoms, then we would definitely get this energy, and this energy. But what if we are having only two atoms? So if we are having two atoms, then electrons will move directly to shell number 3. But when it comes down, there are two ways of coming down. So we get all three photons which are given in the question. So if we have two atoms, then also we are going to get these three photons, and if we are having three distinct atoms, then also we are going to have these three photons. But suppose if you have single atom, then either you may have this, or either you may have these two, or either you may have this. So the combination of these three is not possible in single atom, so this option is wrong. In two atoms also this situation is seen, but in three atoms also this situation is seen. So which makes this as the more appropriate answer. So our D option is the correct answer.